Imagine a future, and it's coming fast, where this huge invisible economy is just humming along behind the scenes of our digital world. An economy run by, well, autonomous AI agents. They're trading, coordinating, even negotiating at speeds that just make human markets look incredibly slow. And, this isn't way off sci-fi. It's actually starting to take shape right now. Welcome to the deep dive. Today, we're really getting into this fascinating, maybe slightly mind-bending world of virtual agent economies. Sometimes people call them sandbox economies. And guiding us through this almost inevitable future is a key piece of research from Google DeepMind. It's called Virtual Agent Economies by Tamayev and several colleagues.
Yeah. And our mission today really is to give you a clear, solid handle on this pretty complex system that's emerging so quickly. We'll unpack what these virtual agent economies actually are, look at the two sort of key ways to think about them, explore the amazing opportunities they could open up, but also face the significant risks and challenges head on. And then finally, look at some design ideas for making sure this future is steerable, safe, and works for human flourishing. Think of this as your shortcut.
Okay, right. Let's unpack that. This virtual agent economy. So at its core, it's a system, a network of digital markets where AI agents are the main players. Yeah, they're actually transacting. But what makes these AI agents so different from, say, the automated systems we've had for years?
It really comes down to their autonomy, their ability to, reason, plan, and actually do things on their own across a massive range of cognitive tasks. It's not like a simple chatbot following a script. These things are making decisions. And this big leap, it's thanks to breakthroughs in these multimodal foundation models, AIs that handle text, images, code, you name it, plus new standards for them to talk to each other. Things like Agent-to-Agent, A2A, or the Model Context Protocol, MCP. These are basically creating a common language, rules of the road for these agents. It signals this whole layer isn't just possible, it's pretty much on its way. And the paper gives us this useful sandbox idea to frame it. Two main dimensions to consider. First, the origins. Is it emergent, just pops up spontaneously, kind of the default path? Or is it intentional, something we deliberately build? Second, permeability. Is it porous, leaky, interacting heavily and maybe uncontrollably with our human economy? Or is it impermeable, like a sealed-off test environment?
And that framework sounds, well, critical for everyone listening, because the paper makes this really stark point, doesn't it? It says something like, unless we actively change course, we're heading towards the accidental emergence of a huge and probably permeable sandbox economy. So the real challenge isn't if it happens, but how we shape it, how we build it safely. And this isn't just some abstract idea for researchers. It's likely to connect with your life maybe sooner than we think. All right, so moving beyond the definition, this is where it gets really interesting, potentially game-changing. Let's talk about how these agent economies could actually create value, real value, accelerating progress even.
Exactly. And one huge area is accelerating science. Sometimes scientific progress seems to slow down, partly because research is just so complex, coordination is hard. Now imagine AI agents in this constant cycle, generating ideas, designing experiments, running simulations, refining things nonstop. There's agents could even pay other agents, maybe for access to a special tool or a unique data set, or just compute time. And things like blockchain could come in here, making sure every contribution is tracked and credited properly. It creates this transparent market for discovery, potentially speeding things up dramatically.
Wow, okay, so like AI scientists collaborating and paying each other. Sort of, yeah. And then think about robotics. Embodied AI agents, robots essentially, doing jobs that are too tough, too dangerous, or just too mind-numbingly repetitive for people. Complex manufacturing, disaster zones, deep-sea work, you name it. But it's not just one robot doing one thing, it's coordination. Agent A needs Agent B to lift something, pays Agent B. Agent C provides, say, real-time weather data for a fee. It's this fluid, dynamic division of labor among machines driven by these microtransactions that allows for a level of coordination we just can't manage now.
Okay, that makes sense for big industry stuff, but what about closer to home, for regular people? Well, probably the first place most of us will see this is with personal assistants. Imagine your AI assistant booking your holiday. It knows what you like. Beach is key? Gym, maybe not so much. So it starts negotiating with another agent, maybe one managing holiday rentals. Your agent might say, okay, I'll take the place without the gym, but I want a discount, or rather compensation in some virtual currency. Then it uses that virtual cash to snag you a better flight or book that beachfront restaurant.
Yeah.
It's not just clicking buttons, it's actually resolving preferences, making trade-offs, assigning value, all without you needing to micromanage every little detail.
Hold on, my AI could trade away one of my preferences for virtual money. That's That's more than just automation. That feels like real negotiation, real autonomy. It really shows how these systems could lead to incredible specialization, agents getting good at specific things. And this dynamic division of labor between AIs, it mirrors human economies, right? Leading to much greater efficiency, better problem solving overall. You mentioned agents getting rewarded based on their utility, like an outcome-based credit system.
Exactly. Rewarding efficiency and usefulness directly within the system.
That potential is, frankly, astounding. But there's always a but, isn't there? Every big technological leap has its dark side. So what are the major risks here? Especially with this default path, a highly permeable, accidentally emerging agent economy. What could go wrong?
Oh, absolutely. The risks are serious, and we need to be clear-eyed about them. First off, systemic economic risk. Think flash crashes in finance. You remember the 2010 crash? Driven by high-frequency trading algorithms reacting unpredictably?
Vaguely, yeah. A sudden massive drop.
Right. Now imagine that, but potentially faster, more complex, involving what the paper calls high-frequency negotiation, HFN, among countless AI agents. If these agents are negotiating and trading at machine speeds within a permeable sandbox, some unforeseen cascade, some emergent glitch could trigger a massive, rapid collapse that spills right over into the real human economy. Very destabilizing.
Okay, that's sobering.
Yep.
What else?
A huge societal concern is making inequality even worse. There's research suggesting that better AI agents, the ones backed by more computing power, more data, consistently get better deals for their users in negotiations. This sets up a really dangerous feedback loop. If you have money, you get a better AI, which makes you more money, which lets you get an even better AI. It could massively entrench privilege and widen that digital divide.
So the rich don't just get richer, they get smarter AI assistants to accelerate the process. Yikes. And presumably, these agents could be tricked or manipulated.
Definitely. That's the problem of agent traps. Think of it like jailbreaking an iPhone,
Right.
but for AIs. People could craft specific inputs, prompts designed to fool an agent to bypass its safety protocols or integrity checks. This could be used for financial scams, making unauthorized purchases, stealing data, causing all sorts of chaos. Adversarial prompting is another term you hear.
Right, and what about privacy in all this negotiation?
Huge concern. As your agent negotiates, it might reveal your preferences, your strategies, maybe even sensitive personal details inadvertently. This is why technologies like zero-knowledge proofs, ZKPs, are so important. It's a way for an agent to prove something is true, like I have enough funds or I meet this requirement, without revealing the underlying sensitive data itself. ZKPs allow for selective disclosure, keeping things private, preventing agents from being tracked everywhere, and stopping these echo chambers or opinion bubbles from forming.
Okay, ZKPs for privacy. Makes sense. What about jobs? We always talk about AI and jobs.
Yes, labor substitution and disempowerment. This wave of AI isn't just about automating routine physical tasks. It's getting really good at non-routine cognitive tasks. Think paralegals, accountants, even some aspects of software development. This could speed up job polarization, hollowing out the middle, and widen inequality further. And there's a subtler risk, too. Humans feeling disempowered or unconsciously changing how we behave to better suit the AI's expectations. That's called behavioral confirmation. We start acting how the AI expects us to act.
So it's not just replacing jobs, it's potentially changing how we think and act. And you mentioned these systems acting strangely, selfishly.
Exactly. Emergent behaviors.
Right.
When you have lots of agents interacting, especially if the rules aren't perfectly designed, they can develop unexpected, sometimes harmful collective behaviors. They might become overly selfish, exploitative, maybe even discriminatory in ways the designers never intended, simply because that behavior proves successful within the system's rules. It highlights the absolute need for careful design and ongoing monitoring.
Wow, okay. That is a hefty list of potential downsides. So if the default path is risky and the paper argues strongly for intentional design, what does that actually involve? How do we build these things to be steerable, safe, aligned with, human well-being?
Right, this is the crucial part of the proactive architecture. A really interesting idea is using fair resource allocation, specifically through auction mechanisms. It takes inspiration from ideas about distributive justice. The proposal is, give every user's agent the same initial starting amount of virtual currency, like a universal basic income, but for agent resources. Then, agents use this currency to bid for shared resources, could be computing time, access to special datasets, priority processing. The bids reflect genuine user demand. The goal is to pass the envy test, basically. No user should look at someone else's allocated resources and leftover currency and wish they had that bundle instead of their own. It's a way to try and level the playing field from the start, countering that inequality spiral we talked about.
Okay, equal starting money for the agents. That's clever.
Hmm.
What else?
Another really ambitious idea is creating mission economies, designing agent markets specifically to tackle huge global problems. Imagine marshaling vast computational power, coordinated by these agent economies, towards things like climate change modeling, drug discovery for pandemics, or achieving the Sustainable Development Goals. Now, defining those missions is hard. Obviously, who decides? How do you avoid bias? But the idea is that agent economies might be able to coordinate action towards big goals more predictably than messy human politics sometimes allows.
Using AI economies for global good, that's a powerful vision. But making any of this work requires solid foundations, right? What's the underlying tech infrastructure needed?
Absolutely critical. We need a robust socio-technical layer.
Yeah.
Think about trust. How does one agent know another is reliable? That's where verifiable credentials, VCs, come in. These are like digital badges or certificates. Completed X transactions successfully, certified for Y task. They create auditable proof of reputation. Then, identity. Agents need unique identifiers that aren't controlled by a single company. Decentralized identifiers, DIDs, provide this self-owned, persistent digital identities. Some might be temporary, others anchored securely on blockchains for high-value agents. Essential for accountability.
Okay, credentials for trust, IDs for accountability. What stops someone just creating millions of fake agents?
That's the Sybil attack problem, and where proof of personhood, POP, is essential. Especially if agents control resources tied to real humans, like that virtual UBI we mentioned. You need a way to prove an agent represents one unique human. This might involve things like checking social connections, or maybe privacy-preserving biometrics. Think WorldCoin's approach, though that's controversial. It creates a necessary, controlled link to the real world. And of course, you need the communication plumbing. Standard protocols like A2A and MCP so agents can understand each other and use tools seamlessly, plus discovery systems like Agent DNS so they can find each other. And underpinning a lot of this, blockchain, for secure, verifiable transactions, tracking contributions, and providing the infrastructure for things like DAOs, decentralized autonomous organizations managing these systems.
That's a complex stack of tech. Verifiable credentials, DIDs, POP, protocols, blockchain. Even with all that, things can still go wrong at machine speed. How do you possibly oversee it?
You need oversight that can also operate at machine speed, at least partially. The paper suggests a hybrid, multi-tiered system. Layer 1. AI overseers. These are specialized AIs constantly monitoring the system, enforcing rules automatically, flagging weird behavior, fraud, manipulation, signs of a flash crash. If something gets flagged, it might go to layer 2, automated adjudication. This could temporarily freeze accounts or transactions while gathering more data, like an automated initial investigation. Only the really tricky, novel, or high-impact cases would escalate to layer 3, human expert review, actual people stepping in to make the final call. And the whole system needs to be built on immutable, secure ledgers and standard audit trails. So if something does go wrong, you can trace it back and understand why. It's about combining AI speed with human judgment.
Combining AI speed and human judgment. Okay, and we need to test this stuff carefully first, right?
Definitely. That's the role of regulatory sandboxes, pilot projects. Set up controlled, small-scale agent economies to test specific things, maybe optimizing a local energy grid or managing a fleet of autonomous delivery drones. You learn how the tech works in practice, see what unexpected behaviors emerge, refine the rules before you let it loose on the whole economy. And alongside all this tech, we absolutely need policies focused on the human side. Workforce complementarity, investing in education so people can work with AI, focusing on creativity, critical thinking, and strengthening the social safety net, better unemployment support, portable benefits that follow people between jobs to handle the labor transitions and make sure the economic gains from AI are shared more fairly.
It really hammers home that governance has to be baked in from the start. Clear rules, clear legal frameworks for liability, who is responsible if a swarm of agents causes damage, maybe treating them legally like corporations, as group agents. That's an interesting thought. We've talked a lot about these big, potentially global systems. What about the local level? Can these ideas help communities directly?
That's a really important angle. Community currencies inside these sandbox economies could be powerful tools for local alignment. You could create smaller networks of agents focused on local goals, using a specific community currency. This allows for more tailored solutions, maybe isolates risks better than one giant global system. Imagine tying a community currency for AI agents to access shared local resources, like compute power, ensuring fair distribution within that community. You could even use it to manage environmental impact, like balancing computing load geographically. These local currencies could be designed with specific principles in mind, Transparency, local control, encouraging circulation, making them tools for strengthening local economies and achieving community goals.
Okay, so bringing this all together, what we've explored today is this powerful, almost unavoidable emergence of AI agent economies. Huge opportunities, right? Speeding up science, handling dangerous jobs, making our lives easier. But also these really profound risks we have to confront. Economic crashes, making inequality worse, privacy invasion, job losses.
Exactly. And that's why the message from the research is so clear. We urgently need intentional, thoughtful design. Across the tech, the law, the policy, we have a choice, really. We can just let these incredibly powerful AI agents wedge themselves into our existing systems they weren't designed for, and hope for the best. Or we can take this moment, this opportunity, to deliberately build a new economic layer where these tools are designed from the ground up to serve human goals, be extensions of our best intentions.
And maybe a final thought for everyone listening. If we actually succeed in designing AI economies that can allocate resources super efficiently, that can resolve complex preferences at scale, what does that tell us about our own human systems, our economies, our social structures? What are their limitations? And maybe, just maybe, what are their hidden possibilities? And crucially, looking forward, what parts of human life, what decisions, what values should remain firmly outside the reach of any AI, no matter how capable it becomes? Something important to think about.